Hello everyone. So in this class we are going to discuss about various representation methods of alternating quantities. The first one is the mathematical representation. Second one is graphical representation, and third one is vector or phasor form. Okay. So these are the three methods. The first one I can take. Suppose if you want to represent a sinusoidal waveform, suppose it is a voltage waveform, I can write V is equal to Vm sine theta or omega t. Or if I want to represent, this is V1, suppose if I want to represent V2, Vm sine omega t plus pi by 4. So these are the mathematical representation of two waveforms. How can I represent these two waveforms in graphically? So I can represent graphically the first equation like this. It will start at phase of 0. So I can write 0 at 0 degrees the sinusoidal waveform will start at. So this will be a maximum value they given Vm. So that is the first. This is A. If it is B, so this is a graphical representation of A. Coming to B, graphical representation of B waveform, if it is a omega t, it is started at pi by 4. So if you substitute omega t is equal to minus pi by 4, if you substitute omega t is equal to minus pi by 4, then the V2 will be 0. That means that the V2 waveform started at minus pi by 4, or at minus pi by 4 the value will be 0. To represent on the waveform I can write, so I have to start waveform at this point. Okay, so at minus pi by 4 the waveform started. Why? Because at minus pi by 4 only the waveform, substitute minus pi by 4 in B waveform, so sine minus pi by 4 plus pi by 4, it will be 0, then V2 will be 0, right? So at this point V2 will be 0. So again at 3 pi by 4 the value will be 0. It is 7 pi by 4. So we have to represent these waveforms in a graphical manner. So in a graphical graph sheet, so we have to start a waveform before pi by 4. So that is the graphical representation. If I want to represent on the vector rotation, so it is Vm at an angle 0, that is V1. If I want to represent omega t plus pi by 4, so I can represent pi by 4, it is again it is Vm at an angle pi by 4, it will be 5 degrees, so pi by 4. So these are the three methods of representation of waveforms, and this waveforms, this is called phase difference. So the phase difference between V1 and V2 is pi by 4. So this is nothing but a phase difference. Phase difference. And so at this point of time I would like to tell one point. There are three terminologies we can come across in future. One is in phase, lagging, and third one is leading. So for example, I will take two waveforms like this. V1 equal to Vm sine omega t plus pi by 6, and omega V2 is equal to Vm sine omega t plus pi by 3. So how can I represent these waveforms on a single graph? See here, I can use the single graph. Here it is omega t. This is 0, pi by 2 minus pi by 2. It is, suppose it is pi by 6. It is minus pi by 6. It is pi by 6, and it will be minus pi by 3, and it will be pi by 3. That is 60 degrees. 30, 60, 90. I can represent waveforms here. So V1. So it will start at pi by 6 here. So this is V1. And coming to V2, it is started at pi by 3. So it is not that much accurate, but I can have better idea. So that is V2. That is V2. So here, from these two waveforms, I can understand V2 started earlier and V1 started after some time. So from this point of time, I can write V1 lags V2 by 30 degrees. That means V1 waveform lags 30 degrees by V2. అంటే V2 అనేది ఒక 30 degrees ముందే స్టార్ట్ అయింది, లేకపోతే V1 అనేది 30 degrees తర్వాత స్టార్ట్ అయింది. So it can also be represented as V1 lags V2 or V2 leads V1 by 5 by 6 degrees or 30 degrees. So in either way we can represent. So whether it is, we can represent in leading manner or we can represent in lagging manner. So if you are observing these 2 points, leading and lagging, be clear and be specific here. If you see the graphical manner, we can easily say which one is leading and which one is lagging. Especially in electrical terminologies, lagging causes when any inductor is present in the circuits, the current will lagging, and if any inductor, any capacitor is there in the circuit, the current will leading. So don't worry, we will discuss these points in the next class when you are talking about pure resistive in the network. So when a sinusoidal supply is given to a pure resistor, what will happen? Voltage and current. So if we are giving to a pure inductor, what is the relation between voltage and current? Or if you are giving to a pure capacitor, so what is the relation between voltage and current? So at that point of time, we will again discuss these things. So at this point of time, if you see the graphical representation, you are able to say which waveform is leading and which waveform is lagging. So in this case, I can clearly observe that from graphical representation, V2 starts early by V1. How much degrees it will start early? It is 30 degrees. So that's why V2 leads V1. V2 leads V1 by 30 degrees, or V1 lags behind V2. ఎందుకంటే V2 తర్వాత V1 స్టార్ట్ అయింది. So V1 lags V2 by 30 degrees. In this way we can have a clear idea to say in the words. So we have to frame words from the graphical representation. I think you are very familiar with these 3 representation: mathematical, graphical and vector representation. So if it is leading and lagging, so we can write these things. So in this way we can represent. Okay, so we'll discuss the same things in the coming classes. I think I hope you enjoyed this session. So if you like it, hit a like button. If you have any questions, you can type in a comment box, and please share it to your friends if it is useful, and please subscribe the channel. Thank you. Have a nice day.